All right, hello, happy day for whenever you're looking at this. Again, don't mind me with the crazy. This is what it looks like a day after school. Everything is fine. We are almost through the week. Let's go ahead and start our next lesson. So today we're going to learn about the phrases domain and range. So the domain of a relation is the set of all possible x values or inputs, where the range is all possible y values or outputs. So the domain is a new word now we're using to say x values or inputs. Range, new word to describe all y values or outputs. So there's two different ways we can write domain and range. Well, there's actually three ways. There's set notation, algebraic, and interval. We're going to talk about two of these notations. So the first one we're going to talk about is set notation. Can I move this? I can. So set notation is when we have a relationship that only has certain points. So usually it'll come in a table, a couple points on a graph, or a set of ordered pairs. This is used for something that is it's not a continuous line. It only has a set few number of points. Now when we write these, we use the curly brackets. You can find them on the keypad right where your regular brackets are, and you press the shift key and then that to get them. If you draw a little squiggle like I will, that is also okay. So when we do this, again, the domain is just all possible x values. So I'm going to write my little curly bracket, and then we put a number, comma, until we've listed all possible x values. And we usually put them in order from smallest to largest. So I see a -1, I see a 2, I see a 3, and I see a 4. So that is my domain. Now we'll do the range, all possible y values, and we'll do the same thing. Put them in order from least to greatest. So we have -3, -2, 0, and 1. There's my closed curly bracket. Okay, so again, we put it in order from least to greatest. We simply just list the numbers in order inside a set of curly brackets. These are all of the x values pulled from this column. I can go like this if this helps. And then the range was all numbers from this column, all of our y values. So that is set notation. I want you to go ahead and try that for this table and then this mapping diagram. So make your curly brackets, list the possible x values, make your curly brackets, list the possible y values, and then do the same for the mapping diagram. If you're stuck, come back and play me, or otherwise finish the problem and then come back to check your answers. Pause me now. Alright, so this first table over here, again, I'm going to just start with my curly bracket. This is, again, all possible x values. So I'm listing all of these numbers here in order from least to greatest. So I see a -6, a -1, a 1, a 3, and a 4. And then we'll close the bracket. I'm going to check that I have all the numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. So then now we'll go ahead and list our y values and create the range. Again, now it's all possible y values. So we have -8. I'm going to cross them off this time and see if that helps. -4, 7, 11, and then 13. Close bracket. Alright, so there are my possible x and my possible y values. for the table. Now let's do the mapping diagram. So again, for this one, remember that these are your inputs over on this side, or your X values. On the right side is our Y, or our outputs. Okay, so I'm going to use this side right here for my domain. I have 5, 7, and 9. And then I'm going to use this table on the right side. That is my output, so those are going to be my range. I have 1, 3, 6, and then 8. Beautiful. Okay. So again, listing your numbers in order from least to greatest, all possible X values, and then all possible Y values. Check your answers. Make sure you have them down. If you don't yet, make sure you do. So pause me if you need them. Otherwise, we're moving on. So our next set is what we call algebraic notation. And this is what we use when our relation is continuous / inline. We use inequality symbols here to represent the smallest possible values and then the largest possible values. And so what this looks like, so before I even try this, I'm going to show you, we usually have a number, our inequality sign. Range is all possible Y values, so I'm going to put, oh my goodness, a Y here in the middle, and then again a number goes on the end. Domain was all possible X values, so I'm going to have a number, my inequality sign, X, inequality sign, and then another number. So again, there it is. So domain, all possible X values, so I'm going to put my smallest X value. Up here I'll put my largest X value. Down here I'll put my smallest Y value and then my largest Y value. So I'm going to color coordinate this here just to try and make it a little bit easier to see. So I'm going to go ahead and do my domain here in pink. So again, I'm looking at my x-axis, which is this axis right here, the one that's flat. So I'm looking at what is my smallest number that my graph reaches to the left, and then what is the farthest right my graph reaches. So I see my graph reaching right here. That's the farthest right it goes. Here's the farthest left it goes. This right here is a value of -1 on the x-axis. Over here, that's 3 boxes over, so that's a value of 3. So that means my domain is from -1 to 3. Okay, I'm going to do my range here in blue. So now I'm looking at how my y-axis, I'm looking how high my graph reaches and how low my graph reaches. So let me change my marker to blue now. My graph reaches way up here, and then it goes way down here. This highest number was 1, 2, 3, 4. This lowest number was 1, 2, 3, -4. And so that's what I'll write in my lines here. It goes from -4 to +4. So I can read this as my domain, my graph reaches from -1 to +3. My range goes from -4 to +4. All right, so again, we drew 2 lines at the farthest left my graph reached, and then the farthest right, and then the lowest my graph reached, and then the highest. So what I want you to do next is I want you to try to do the same thing for this line. So I want you to write your domain. So what you need to do is draw a line from the lowest left your graph reaches and then the furthest right your graph reaches. Draw 2 vertical lines and then make the notation look like this. Put the smaller number on the left side, the larger one on the right side, and then for range, find your lowest your graph reaches and then the highest, and then again write it just like this. Put your lowest number on the left, the largest number on the right. Try it and then come back and check your answer. Alright, I'm going to do the same thing. I'm going to color coordinate this here. So I'm going to do my domain in blue. So again, this is going to look like something, inequality, x. Okay, so I'm going to look at the farthest left my graph reaches, the lowest x value. I can draw a line right here. And then the furthest right it reaches, which is right here. And that's at the value -3. Come on. And then 5. So I'm going to fill in the blanks. -3, and then 5. And then now we can do the range. I'll do this one in pink. Again, here you're going to have a number, y, inequality, another number. Again, now we're looking at how high and how low my graph goes. So I see my graph reaching up here, and its lowest point is right here. And that's at the number 2 and the number 4. Smallest number goes on the left, larger number goes on the right. There's your domain and range. Check your answers, see how you did, fix it if you made mistakes, let me know if you have questions. Let's see, we have one last type here, and you're going to move on to independent practice. We have algebraic notation continued. Now we have a story problem. It says the function f of x equals 10 minus 0.35x represents the amount of fuel in a gas tank over the course of a 30-minute drive, where x represents the time in minutes. What is the domain of this function? So we write this the exact same way as we do with the graphs, our domain. So we have a line, inequality, x, inequality, line. And we are finding a minimum number and a maximum number to go here. Okay, well in this case, we really want to pay close attention to what x represents. So in this story, we see here that after the course of a 30-minute drive, where x represents the time in minutes. So if x means minutes, over here on the right side, I put my smallest number of minutes. And over here on the right side, I put my largest number of minutes. Okay, so if we have a 30-minute drive time, that means the largest my drive can be is 30 minutes. And then the lowest it can be is, well, not starting at all, 0. So you want to pay attention to what x represents, put in the lowest number that can be, and then the highest number that can be. So I want you to see if you can figure that out for this problem right here, and then come back and check your answer. Go ahead and pause me now. Alright, so same thing. For this we write a number, inequality, x, inequality, and then another number. We have the function f of x equals 3x plus 7 represents the amount of money a taxi ride costs downtown, where x represents the number of miles. The downtown is only 15 miles long. What is the domain? So here x represents miles. So here I'm writing my smallest number of miles. Over here I'm writing my largest number of miles. So if my drive is only 15 minutes long, or 15 miles long, that means the largest it can be is 15. The smallest is to not have started at all, so 0. Alright, at this point we are officially done, so go ahead and work on the independent practice problems, come back up to these to help you, and shoot me a message when you finish so I can check your answers. Have a good day.